Chapter 5: Preliminary Steps in Developing a Food Safety Plan for Human Food, presented by David Rosson. Before building a food safety plan, organizing information is important. These 5 preliminary steps involve gathering information about the products, processes, and facility operations to build a complete picture of the facility. This information helps to identify potential hazards and preventive control measures when developing a food safety plan. These preliminary steps are not required by the Preventive Controls for Human Food regulation, but the information is useful to provide a sound basis for applying preventive controls principles. These steps are also consistent with U.S. and internationally recognized principles for developing hazard analysis and critical control point HACCP-based food safety controls. A discussion of each of the 5 preliminary steps follows, with examples to illustrate the process. By the end of this chapter, participants will be able to perform the preliminary steps important for developing a food safety plan. Assemble the food safety team. Describe the product and its distribution. Describe the intended use and consumers of the food. Develop a flow diagram and description of the process. Verify the flow diagram. Assembling a food safety team is an important step in building a food safety plan. Management commitment is extremely important to ensure that enough resources are dedicated to this effort. Effective food safety management not only protects the food, it also protects the business from the risk of a food safety incident or a regulatory noncompliance issue. To develop and implement an effective food safety plan, a budget, resources, and support for change management, potential changes in equipment, and new procedures may be required. Without management commitment at all levels, it may be difficult to implement an effective food safety plan. Top management commitment to food safety sends a strong message to all personnel that the food safety system is vitally important to the company. Although one person may be able to analyze hazards and develop a food safety plan successfully, many companies find it helpful to build a food safety team. When only one person develops a food safety plan, some key points can be omitted or misunderstood in the process. The team approach minimizes the risk of missing key points or misunderstanding aspects of the operation. It also encourages ownership of the food safety plan, builds company involvement, and brings together people with different areas of expertise. At least one member of the food safety team should be a preventive controls qualified individual who has successfully completed this FDA-recognized food safety training curriculum, or who is otherwise qualified through job experience to develop a food safety plan. The preventive controls qualified individual does not have to be an employee of the facility, but it is beneficial for a facility to have at least one preventive controls qualified individual on staff for food safety plan implementation activities. The team should consist of individuals with different specialties and experience with the facility's processes and procedures. The food safety team should include members who are directly involved with the daily operations of the facility and may include personnel from maintenance, production, including equipment operators, sanitation, quality assurance, engineering, purchasing, and laboratory, if applicable. These individuals develop a food safety plan under the oversight of a preventive controls qualified individual and verify ongoing implementation of the food safety system. The team members should be knowledgeable about food safety hazards and food safety principles. When issues arise that cannot be resolved internally, it may be necessary to enlist outside expertise. In small companies, the responsibility for writing the food safety plan may fall to one person. If it is possible to build a food safety team in a small company, employees knowledgeable of various functions, including owners, should be members of the food safety team. Universities, cooperative extension, consulting groups, and trade associations can provide additional assistance through food safety plans, published guidance, and, in some cases, personal assistance. In addition to writing and developing the food safety plan, the food safety team provides oversight of the implementation of the food safety plan during the daily operations of the facility. This includes ensuring that personnel are trained to perform their assigned duties. Members of the food safety team may also be tasked with the development and implementation of standard operating procedures as part of the prerequisite programs, especially where those procedures support the food safety plan. Throughout the class, a fictional frozen omelet manufacturer, the E.G. Food Company, is used to provide an example. The slide contains a description of this fictitious company with some information about how the organization operates. This description helps visualize the operation. Take a minute and review Appendix 3, attached in the chapter Resources. E.G. Food Company's food safety team consists of 4 employees: the plant manager, I.N. charge, the quality assurance manager, FS leader, the production supervisor, EFNC, and the sanitation supervisor, IM clean. All have undergone food safety training and use references such as FDA guidance documents. Additionally, an external food safety consultant, PH Books, has been brought in by the E.G. Food Company to assist with the development of the food safety plan. The consultant may be tasked with ongoing work such as performing the annual review of the food safety plan, as well as making any needed modifications to the plan. The facility collected input for the sanitation program from the sanitation chemical supplier and included aspects such as the appropriate cleaning and sanitation compounds, as well as proper procedures for its sanitation procedures. As a reminder, documenting the food safety team members is optional and not required by the preventive controls for human food regulation. Appendix 3, in the chapter Resources, Food Safety Plan, Teaching Example, contains a full food safety plan, which will be used for examples throughout the course. Understanding basic information about a product and its distribution helps to determine what specific food safety controls are necessary through the distribution cycle. The food safety team should describe the product's food safety characteristics, ingredients used, the type of packaging, shelf life expectations, and the methods of storage and distribution. Information on intrinsic properties of products or factors that can influence the growth of pathogens, e.g., pH, water activity, preservatives, if any, is important. Along with this, an understanding of how these elements impact food safety with regard to potential food safety hazards that may require preventive controls. A product description form is a helpful record to capture product and distribution information. Appendix 2 in the chapter Resources contains template forms for review and use. Other formats may be used, rows may be deleted, and a simple paragraph format is also acceptable. The preventive controls for human food regulation does not mandate capturing this information. However, the information contained in this form can be useful to provide an overview of the product to an independent auditor, e.g., when an audit is required by a customer or a food safety consultant who is helping the food safety team to develop a food safety plan. The information contained in this form may also be useful if a recall is needed. Additional details on recalls can be found in Chapter 15. Recall, Plan for Human Food. There may be other information that could impact food safety hazard analysis beyond what is documented in the product description. When identifying the ingredients used, collecting information on processing aids as well as other allergens handled in the facility can help to give a more holistic view of the operation to help with identifying possible hazards that may be specific to the facility. This will help to ensure that the hazard analysis is complete by considering other potential concerns. Intended use of the product refers to its anticipated use by end users, e.g., other food processors, consumers, etc. Most foods are likely to be intended for the general public. The food safety team should consider these questions. 1. What is the intended use of the product, e.g., retail, food service, further processing? 2. What is the potential for mishandling by the consumer and unintended use by them? 3. What handling and preparation procedures are required of the end users? For example, is the product ready to eat, or does it require further preparation such as reheating, cooking, etc.? 4. Who are the intended consumers of the product? 5. Is the product intended specifically for use by immune-compromised individuals or other susceptible groups? Answering these questions provides valuable information for the food safety team as they proceed to the hazard analysis. See Chapter 6, Hazard Analysis. Intended consumers may be members of the general public or a specific segment of the population that is more sensitive to certain hazards, typically referred to as at-risk or susceptible populations. These groups include infants and young children. Infants and young children do not have a fully developed immune system and are more likely to develop certain types of foodborne illnesses, such as infections by bacterial pathogens. Choking hazards from the food itself or packaging material, e.g., small caps, may also be a concern for this group. Elderly persons. As people age, their immune systems naturally weaken. Elderly persons tend to be more susceptible to infections by foodborne bacterial pathogens than the general population, and illnesses may also be more severe. Pregnant women. Some pathogens, such as Listeria monocytogenes and Toxoplasma gondii, are particularly harmful to the developing fetus. Manufacturers of foods targeted specifically toward pregnant women should control potential sources of these pathogens. Immune-suppressed persons. Other factors can weaken the immune system. For example, persons who are HIV positive, have had organ transplants, are undergoing chemotherapy for cancer, or who regularly take acid reflux or immunosuppressive drug therapies, are particularly susceptible to developing illnesses caused by foodborne pathogens. As modern medical treatments improve, it is important to recognize that a relatively large percentage of the population fits in this category. While food targeted to the general population may be consumed by these vulnerable groups, food specifically designed for susceptible populations, e.g., for hospitals, nursing homes, may require more stringent controls because these foods will be consumed by at-risk populations. On this slide is an example of a product description that will be used to illustrate the progressive development of a food safety plan for omelet products produced by the fictitious E.G. Food Company. Note that in this example, the potential for abuse is identified in the intended use section. The product description, distribution, consumers, and intended use form described yes in Appendix 2 in the chapter resources and can be used to record this information. This information helps to assure an accurate hazard analysis but is not required in the regulation. Elements of a complete product description and intended use form product names, may include more than one product with similar processing and hazard profile. Product description, including important food safety characteristics. A general description of the product and processing method, assembly, and group or type of products included in the category. If it is relevant to product safety, intrinsic properties like preservatives, water activity, and pH should be listed here. Ingredients. Simple listing of ingredients, including processing aids, which may be grouped or transferred from the product label, if convenient. This could also be an attachment, a list or a recipe, or reference ingredient specification numbers, which would provide more detailed information. Packaging used. A general description of the packaging, including method or type, such as hermetically sealed container, modified atmosphere, or vacuum packaging if used. This may impact the hazards of concern. Intended use. Describe the normal expected use of the food, e.g., ready to eat, ready to cook, raw, and, if useful, where it is sold, e.g., retail, food service, schools, long-term care facilities, etc. May describe a complex distribution system if desired, e.g., frozen distribution with refrigerated or ambient display, used for further processing, etc. If unintended use or abuse is likely to occur, e.g., eating raw cookie dough, this should be identified. Shelf life list intended shelf life, if relevant to potential microbial growth or age-induced toxin formation. Labeling instructions include label instructions relevant to food safety. This may include refrigeration, cooking instructions, etc., if relevant. Storage and distribution. Lists the method of distribution, e.g., refrigerated, frozen, ambient. A flow diagram provides an important visual tool the food safety team can use to describe the process. When developing a process flow diagram, it is important to include all the process steps within the facility's control, from receiving ingredients and packaging through final product storage, including the use of water and ice as an ingredient, rework in facility manufactured ingredients, and diverted byproduct, if applicable. Each process step should be considered in detail and the information expanded to include all relevant process information. Information may include all ingredients and packaging used, where raw materials, ingredients, and intermediate products enter the flow, the sequence and interaction of all steps in the operation, including in-facility manufactured product, if applicable, and alternate processes that could be used. An example of substitute equipment or seasonal production could be the use of fresh produce when it's available in season, then reverting to frozen when it is not available. Where product reworking and recycling take place in the process, and where product is diverted to waste or rework, if applicable. An example in dairy processing is the flow diversion valve, which reroutes improperly pasteurized product back to the beginning of the heating process. The product flow diagram for the EG Food Company omelet example appears on the next slide. The EG Food Company's product flow diagram shows the receipt of their ingredients and packaging, as well as the storage of the ingredients and packaging. Each processing step is outlined in the flow diagram, showing the crack eggs and mix step, cook step, omelet assembly, wrap step that includes the post-process addition of the ingredients, cheese and biscuits, spiral freezing, metal detection, and packing into pre-labeled carton, after which the product is placed into frozen storage and finally distributed under frozen conditions. Each step shown in the flow diagram will inform the hazard analysis process. A written process description is useful to explain what happens at each of the process steps and can contain more detail than the flow diagram. This description can be used as a working reference for the development of the food safety plan, particularly the hazard analysis. The food safety team may already have other documents that contain similar information, such as product specifications, recipes, or work instructions that can be used in place of the description illustrated in this chapter. It is important to know what occurs at each process step. For example, information which may have an impact on food safety, such as the maximum length of time that the product could be exposed to unrefrigerated temperatures, the maximum room air temperature, or the internal product temperature after a process is important to know for an accurate hazard analysis. The beginning of the process description from the e.g. food company example appears above. C. Appendix 3, Food Safety Plan, teaching example for the full process description. The steps in the flow diagram are used to organize the hazard analysis and determine preventive controls, which are discussed in Chapter 6, Hazard Analysis, and Chapter 7, Preventive Controls Determination. Since the accuracy of the process flow is critical to conducting a hazard analysis, the steps outlined in the chart should be verified at the facility. If one step is missed, a food safety hazard requiring a preventive control may be missed. Include every handling, processing, and holding step for the product, as well as ingredients and packaging. The food safety team should walk through the facility and make any changes required in the flow diagram. At the same time, the team should make observations related to sanitation, potential for cross-contamination or allergen cross-contact, and potential harborages or introduction points for environmental pathogens. The walkthrough allows each team member to gain an overall picture of how the product is made. It may be helpful to invite additional plant personnel to review the diagram during the walkthrough. Many times, operators can identify issues that may be overlooked by management or the food safety team. The complete verified flow diagram should be retained and periodically evaluated as a food safety record and as part of the food safety plan. A signature or initials is used to indicate that the flow diagram has been verified. Food safety plans are dynamic and must be updated to reflect any changes in process or food safety considerations. Therefore, any significant changes to the ingredients and packaging used and the process should be accurately reflected in the product flow diagram, and the food safety team must evaluate if these changes have an impact on the hazard analysis and preventive controls in place. It is important to have the right people in place and information available on the ingredients, packaging, and processes used before applying preventive controls principles to develop a food safety plan. Preliminary steps include 1. Assembling the food safety team and ensuring that there are multidisciplinary perspectives who can provide appropriate expertise into process. The goal is to get varied input to help ensure that an accurate assessment of the food safety hazards that exists for the products being produced. 2. Preparing an accurate description of the product and its distribution to understand the characteristics of the product and ensure that potential hazards are not overlooked. 3. Identifying the intended use and consumers to ensure that preventive controls used will protect the safety of consumers during intended use and acknowledge potential misuse of the product, as well as ensuring that potential hazards are not overlooked. 4. Creating a process flow diagram that provides the organizational framework for conducting the hazard analysis, which identifies preventive controls to prevent food safety risks for the consuming public. And 5. Verifying the flow diagram and operational conditions to avoid overlooking sources of potential hazards. If a facility produces more than one product and several food safety plans are needed, it is recommended that the food safety team keep its tasks simple by only attempting to develop one plan at a time. The team could have the first plan reviewed by an external expert before addressing additional plans. This can help to ensure they correctly identify the hazards requiring preventive controls. You have completed the lecture for Chapter 5. Be sure to complete the knowledge check as well as the Chapter 5 exercise. See you in Chapter 6.